Well, good morning. It's Don Dyer, factory trained and certified Harley Davidson technician. Well, you know, a lot of old people I know watch this, and maybe some young people might enjoy old tools, but here's one of my favorites here. Let's see if I can get that in there. What this is a Powermatic Model 65 table saw in just great condition. There's a company that sold it, Portland Machine. See that? Isn't that slick? Well, this was at the local college, and I bought it just before the COVID thing. They had an auction over there, and I walked over there, a bunch of desk and garbage, and there's this thing laying on its back for $100. And I go, I want it. Well, what we need to talk about is up on top. Let's have a look at that. I got a couple of conventional gauges I want to show you that are useful. And I think a lot of my machine shop viewers are getting into surface grinding, and I'm going to do a little demo of surface grinding one of these bearing spacers, a Timken bearing spacer. It'll take me both hands to get that out of there now. Now this gauge here I wanted to demonstrate is an old time gauge. It's a Brown & Sharp number 730. I forget exactly what they call this thing, but it's well over 100 years old in design, and this one could be 100 years old anyway. And I'll show you an application of that. Let's get this camera on a tripod. I'll be right back. Yeah, I think that looks pretty good for what I want to show you. Now, I mentioned on this K-model project, I'm going to drop the compression down because the engine will eat itself up. So I'm going to drop that compression down and get the power down on the thing to make the thing work. Now, the way I'm looking at this, I'm going to preserve what is there and get it running. So if someone later on is more motivated, they could easily pick this up and try for a total restoration on that motorcycle. Now, on removing metal from pistons, you got to be careful there. And I'll show you an old-time gauge here that I used to do that. So we got a piston here. I hope I don't get in the way. And this is a 2-inch travel starret indicator on there. So there's usually have a little tab to pick up, but I can't find it. So you can lift that up. Well, first you want to set it to 0, and I got it on the number 2. Okay, it's loaded 200 thousandths, but that's 0. When it's on the 2 and 0, that's where it goes. So let's measure the thickness of this. Just that easy, right there. And it is 258 thousandths thick at the top here. Okay, that's 260 thousandths. Now you don't want, it starts getting iffy if you start getting to 125 thousandths. You know, then you're getting to a point that you can burn a hole in the piston. Now, one of the reasons I do this, and one of the things, see, it's returning to 0, is valve pockets. And if you're building engines that have a cam with duration, and that means both valves are being held open at the same time, you know, at the exhaust stroke, where it keeps the exhaust valve open and uses the velocity of the exhaust escaping to pull more fuel in. So in that duration time, the pistons at or near the top, and the valves can hit the pistons. So you have to do these valve pockets, okay? Here's an old-time piston here, an old shovel head import high compression piston. You can tell high compression shovel head pistons because they have a cast top. for the most part. And if they're machined, then they're a low compression. That makes sense, doesn't it? This is a high compression copy of a Bonalite piston. And they have an expansion strut. They use these from the, a long time, from the 40s and maybe even earlier, to the last of the shovel heads in the 80s. So I can measure this valve pocket here like this. Take that, lift that up, and you take that little, this is just a piece of ground steel on the bed of this thing. So I got it in that pocket. How thick is it? Pretty darn thick. These are thick. If I can get that, there it's sitting on there. It is really thick. It is 1, 2, 3, about 400 thousandths thick at that pocket. So you can cut quite a bit off these. Usually didn't do much to old shovel head stuff like that. But this is an S&S piston here. Forged piston. For Evo, 3 5/8 bore. And it's probably obsolete. They put a lot, this is old, they put a lot of little handwriting in there. They were doing a lot of experimentation. And I was an S&S dealer for more than 15 years. Then we had the S&S at the dealership, at the Harley Davidson dealership. Okay, so this pocket here is 320 thousandths on that valve pocket. So you can really whack quite a bit off those. So on those, they're still out in the garage there, the flat top K-model pistons. I'll go ahead and take 50 thousandths off the top, start dropping that compression down. Okay, this is an antique gauge that you can see I just measured the thickness of pistons with, and that's how I did that. Okay, now let's get over to this gauge here. Okay, get that. Let me see if I can drop that a little bit here. Get right in there. I'm doing it out here because we'll go where the grinder is, and it's just a little bit more. Let's see if you can see that. Now, this anvil here on this is serrated, and I'm showing this specifically for grinding spacers, and there's a whole bunch of them in the motorcycle engine. This is the Timken bearing spacer for a big twin, and I'll show you over in the shop bulletins some interesting information on that. So here's what I do. You check the in play on your motor, and then you want to get it to a specific place. So you might want to take 2 thousandths off this thing. So you stick this thing in there and find out where it is, and you can zero it or set this up so it actually reads. But it's not good to measure things this way. You know, you want to get it to where you're just measuring other ways than using this to knock what you need off. Like it might be 2 thousandths or something like that. So you just set that over there, and then put this in the grinder, grind it, release it off the magnetic chuck, bring it over here. You see the serration? If it was flat, you'll have crap stuck to this thing. You'll have micro particles, grit, and stuff like that. But this anvil here, it's probably carbide. it's serrated, so when you put it on there, you can kind of just slightly rotate it, and it scrapes the particles off. And you can feel when it's making contact. This isn't the normal gauge I use on this. Kind of hard to grab here. You see it's repeating real good with intense. Each one of these spaces here is 1/1000. This really pretty handy half-inch travel aims indicator that reads in thousandths. But then you can kind of inspect things to see if they're actually like they're supposed to be. And I found that this thing's off about 1/2,000ths from the factory. So when I grind it, it's actually going to be more accurate than Timken supplied it. Okay, we'll get over to the grinder. We'll make it work. Well, as can be seen, I'm still working on this area here. This is in the basement, and yes, that is a surface grinder, and that is the sun and hone, the top part of it. There's a back cover, and I'm cleaning that unit up. It's gonna be as clean as a whistle. And sometimes what happens is over the years, in the oil and stuff in it, it just gets a coating on everything, and it got so sticky I could not properly adjust the machine. And you go through a routine, it takes you a little while adjusting all the little gizmos to make this thing work. And I will explain this machine as best I can. And the one thing about this machine is this is really a machine. You learn the most by actually using it, but I can get you off in a pretty good deal here. So I got the surface grinding here running. I always run machines for a little while before I grind or use them, just because. So the oil is up. That's the oil indicator there, oil indicator window. So I start rotating this table back and forth a little bit. And I'm gonna tell you how I do this with this grinder, how I use this grinder. I've gotten quite intimate with this grinder because when I got it, I had to scrape the ways, okay? And I've learned, and from other people too, some little tricks to help preserve your grinder just a little bit, okay? And I'll show you what I'm gonna do. So I'm rolling this thing back and forth, and it's all lubed up, right? Then I'm gonna do this. Watch this. I know where to put this, but I'm just gonna go like this. Then I'm gonna move it over here, and I'm gonna do a little bit more. And over here, right about in there. Then I'm gonna roll it here, and I'm rolling it back and forth there. And what I'm finding is it's a little bit tighter. It feels a little bit tighter. It's a little bit loose right here. Let's roll it over here. Starting to get tighter, 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 loose. Right there, you see that? So I'm going to roll this over right there. Right about there, it feels tight. And that's where I'm going to grind this spacer. And that'll help equalize the wear out on this. Okay, I need both hands, so I will be back. But take a look at this photo I'm going to put up right now, and see if you can find me in it. I just completely goofed up a video, so I got to do this again. Now, I'm grinding these small rings here like this, right? So I got a ruler, 6-inch rule, and I'm putting across there. Got the ring on there in a good spot. Excuse me. Right about there. Engage the power. Make sure it's not going to fall off. And I'm going to fire it up. And I'll crank it this way. Now I usually use flood coolant. And I'll have that hooked up pretty soon because I like it quite a bit better than grinding dry. So I'm going to get this under there and I'm going to just touch it. Make sure I'm close. I'm getting close. There we are. Okay, back this way a little bit. We'll just start grinding that. I'm going to give it a quarter turn on this, feeding about 25 thousandths. We're just skimming off a couple of tenths here. I hope you're all doing well today, and your grinding is going as good as mine. This grinder actually puts a better finish on this spacer than 10-pin did, and actually making it flatter. I found this a little bit out of whack. It might not be critical or something, but you don't like to see stuff like that. And I almost always grind these spacers, so I avoid problems. Just about got it across there. So let's say want to take a thousandths off this thing, or a thousandths and a half. So I just got this thing kissed, right? And so we know it's at 0. So I can gauge it and go from here. Looking good. Now you want to keep flipping things because grinding work hardens the surface and it will cause this thing to warp. Now we're getting to the edge there. Just skim it over here. Get the end of it, the same treatment the rest of it's had. I find it very difficult to video stuff like this. It makes it a lot harder. You're not thinking about a video or something like that. Just kind of breeze through it easier. Okay, I'm going to leave the grinder going. I'm going to reach up here and I'm going to set this to 0. At 0. Okay. I release the part and we're grinding on that side. So I'm going to hold it like this so I keep the orientation good. And I'm going to try this. Let me move this stuff. Oh, let me get this here. This made this hard. So I tried to move the camera over there, and I don't have this area finished, and it's going to take a while. So the serrated anvil You can rub this back and forth and you get all that grit, little residual magnetic particles. So I'm going to try to carefully lift this up and get it on there. Get this gauge on there. Let me rotate it just like that. And I'm going to zero it. Well, let's see, where are we there? Okay, let's say we want to remove 1/2 thousandths. So I set that 1/2 on the gauge here, see? Okay, let's get that out of there. This is a mid-tutorial stand, by the way. And I'm going to try to carefully pick this up, get it out of here. And we'll go back to grinding. So I'm going to put this back on there. I have the orientation right. I ground that side. Isn't that nice? Look at that. Now I'm going to grind this side. I'm going to ring it into the chuck and bring it up against the rule. Energize it and check it. Always check. Okay? So I'm going to crank it over this way so we can see it come out ground. And I'll get the orientation with the wheel just right. Looks good enough. So we go back up here. This reads in tenths. That'll be a, no, it reads in half on this one, I believe. Yep. So this is it right here. 1/2 thousandths. Now I can put in, I'm always going to get around to putting a DRO on this, but when it gets real tight, I can just put an indicator on it and it's worked. But maybe I'll put a DRO on this thing. I don't know. It would be kind of cool, I think. I should have done it a long time ago, right? No, I got to hold this up or I'm going to crash into my hand into this. Might even be too much anyway. Okay, I'll start grinding. We'll see where we are with this. Okay. Here we go. Oh, I got to go this way. You always want to go into it. I almost climbed it. But I take such light cuts, it's usually okay. I feed this thing at about 25 thousandths. And the best way to do it is the way that works for you. But I wanted to show you about backing it up with that, just using a ruler, keep that thing from sliding on you. I found this ring kind of has a bad spot on it. And it's brand new. So it's really good to look over everything. You know, don't take anything for granted on these. Because one of the problems is they're very delicate. In one way is if something goes wrong, it's going to destroy a whole bunch of expensive stuff. So you want to pay close attention to details. Just like a hydrostatic transmission. You don't want that to go bad on a heavy piece of equipment. It'll take out everything too. Contaminate the system. So you want all this stuff you work on to be like that, and Harley Davidson's. You know, it's kind of funny. Obviously, Harley Davidson's in a very tight situation right now, and it doesn't look real good for them or other motorcycle manufacturers, except probably Honda. But motorcycles are really at a low interest rate. People are just kind of getting away from motorcycles and a lot of mechanical things in general. I think even automobiles are starting to get vintage cars and all that stuff is on the decline. I know machining's on the decline. Old Robert at the junkyard says the way it is now, if you can't do it on your phone, it ain't worth doing. Okay, so we got that clear. And release. And I usually, if I grind this side, just so I remember, don't have to mark it, I'll just flip it in my hand and hold it like that and know this is the side that needs to be ground next. And I'm going to get that gauge back up here and be sure to get the camera on it. Let's see. Okay. Let's see what it reads. Get it in there. Get the anvil on there. Then I'm going to just kind of move it back and forth. And that'll scrape that grit off. And where are we? Not where I wanted to be. I could have moved the gauge too. You know, well, it's getting more there. No, it's not. Let me see where we are here. Yeah, well, look at that. I think I'm having a little bit of stickiness with this, but I wanted to get on 0, and I'm a 1/10 from it, and that's good enough for what this fit is. Hey, I just wanted to show you this, and it goes a little smoother without trying to film it. Look at that, it popped right on 0 where it's supposed to be. So I hit it. I did it. Okay, I think we'll meet out in the shop next. Okay, what we have here is the service bulletins. They were never released to the public for good reason. You don't need to know this secret stuff, really, do you? Okay, now here we are. This is June 23 of 1969. But first, I'm going to remind you of right here, October 13th, 1975, warranty coverage, modified motorcycles. Please inform your customers that any alterations to the motorcycle outside of factory specifications may void the warranty. This provision is specified under item 7 of the motorcycle warranty statement, blah, 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 blah. Okay, prohibited alterations made before the sale or during the warranty period would include front forks. That's a safety thing. Exhaust system, and what are these other blah, 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 blah. Okay, on and on and on and on and on. So, they say the same thing now, but I wanted to point out that they said the same thing then. Okay, in the 75. I got the shop notes up to 82, I think. You can see right here. You see that? I had to sign that for the chief mechanic. Now I had to sign that, and the factory representative would come by and make sure that I read these things, that I knew what was going on. Now this is one of the most interesting things here, is fitting cam gears and stuff. Now remember I was let me get that up there. Here's the cam gears and stuff. Now remember I was talking about the inaccuracy in the manufacture of these motorcycles back in the day. Now, what happened was their equipment wore out. They had new equipment from the mid-60s, but then by the time, what is this, around the 70s, 10 years later, the equipment was worn out. And what happened is they couldn't locate the holes very good. There's this is your pinion shaft right here in this illustration. That is your breather gear, and this is your camshaft. This is a big twin. The Sportsters are much more complicated. So what they did, they color-coded the gears. This one and that one. And the breather gear just spins. So they color code these with different pitch diameters. And you measure the diameter with pins across the teeth. They tell you how to do that. So they color coded the gears. Orange being smaller diameter, gear pitch diameter, with black being the largest generally. Depending, I guess, on the gear. They're calling this one brown and red. And here's the numbers you're supposed to get, or the parts, I don't know, size inches right here, measured across pins. Look at this stuff. Crank pin, 84 to 79 XL. There's a lot of stuff on these on this stuff here. And look, they introduced 3-angle valve seats in 1980. You can see right here. That's kind of interesting. I had to sign it. The factory recommended using new way cutters by this time for doing your valve seats and stuff like that. Here's measuring the cam gears using pins. Okay. So we're back here to the in-play, and in the this is pretty interesting. I found it so, and I asked about it. Was if you look in the manuals, they'll say for the electric light it is like 1 to 4 thousandths of an inch, but here in the shop notes it says 0.5 to 6 thousandths. And the Sportster was always wider, but in the shop notes it says up to 10 thousandths in play. And you don't want to do that, but what this is about is they tested it. And if you got a bike or something, you're looking at a motorcycle and you're checking the in-play, oh my God, it's got 6 thousandths. This will tell you, well, it'll run at that, but they're not saying how long. So, you know, if you look at this, it'll run at 5/10 thousandths. And maybe it should run, you know, at that, but I've always set it at 1, okay? And I've always set the Sportsters at 1. I try to keep it at 1 thousandths. And that's why I use the surface grinder. Okay, I think we are done down here. I probably screwed everything up, but bear through it. Now I'm going to go outside and take a look at what's coming. Hey, I have to show off my latest find. Look at that. You see, some of my videos that I walk down old roads and stuff like this, and this was out in a field, and it was being shot at. Look, it got hit there. Got a good hit right there. Look at that. And here. But it didn't put a hole in it. That's a goldenrod. It was full of gear oil, or it had some gear oil in it. What it was is just a yellow speck out in the field. And I looked at that and I go, what is that thing? And I went and walked out there, and wouldn't you know, it was one of these. So I got hit 1, 2, 3, 4, 5, 6, 7, 8, maybe 9 times at about 100 yards. Okay, now back to more serious things. Though goldenrod oilers are serious. Okay, I got the crankcase on the incredible, the invincible Brown & Sharpe number 2 plain standard heavy mill. Really a cool machine here. It cost me $500. But it took a lot of work to get it to this point. But it's in very good condition, and it's good enough to use this, to do this function. Now I'm going to finish it on the jig bore, is relocating the dowel pin locations. But before I can do that, see, this thing's been welded and several places, and then this warped case was bolted to the non-warped case, and it's warped too. So every surface, every interface on this thing has to be checked and cleaned out. Now, to get a start, and this is a non-critical surface that is down on the table and is the primary cover. There's no bearings in that that are going to cause any kind of problem. So that surface can be off a little bit, okay? But it's a funky surface now because it's been welded and it's broken through on the bottom. So what I'm going to do is this surface that's down here, I'm going to clean up first. So this thing's been kicked around and stuff, and this is very basic, is I'm going to take the file, this very large lathe file, and it's really quite fine. And I'm going to slide it all around these places. You can take the handle off, but I don't think I need to. Flip it so I don't hit it with that screw. See, I can feel it drag. This is badly warped through here. So I'm just going to take all the high spots. You'll find raised spots where the bolts are. You see what I'm doing? We're going to machine this side now. Now I just want this thing to lie as flat as possible. See, I can feel it grab here, and you can actually see where it's picking up. See, this thing's not flat. See? It's raised up in places because it's warped. And these things will warp on their own. Remember, this is a unit construction, a stressed member of the frame. So let me swing this over. I'm working around the camera as usual. But I just want to show you this. This is very critical. See, I'm feeling it grab right there where it's gotten bashed on the bottom. Just kicking around. Being a motor in pieces doesn't help. So I'm sliding this file. Slide it back easy. Bear down on it. I'm going clear around this. I can feel that it's not very flat. Okay, I've pretty much gone clear around it, and I'm not feeling much for raise. The file's gliding, see? I glide that file there. I'm going to go across here. Yep, picking up something there. I'm going to go across here. Easy. Okay. Just kind of want to get it some different directions, you know. You can really see how it's burred up right there. So I want to be sure. Get all that. Okay. that's good. So now, boom, I'm going to set this down. Let's kick it this way. Okay, it's setting on there. Look at this. This table's flat. This is an accurate milling machine. Okay, I'm not too worried about this, but I tell you what I'm going to do. I'm going to take shim, and I'm going to shim this. I'm going to shim the warp part so I'm not pulling it down and putting any stress on it. I'm going to pull it down and have the low spots shimmed and go for little stress as possible. This thing's had enough stress in its life, don't you think so? How about you? I'm sure you've had enough stress in your life too. So we do things like this to reduce our own stress. Because in the end, we want this to work, right? This has got to work. So, okay, I'm ready to shim this thing up and bolt it down and then fly cut this. I'm going to fly cut it. And there's some things there I want to show you and talk about. And you can see the welds here, warping the crap out of everything. Look at that. Yeah, you don't want to pull something like that down crooked, because when it comes back up, this surface won't be straight. You see, I want the gasket to seal in the primary here so it doesn't leak oil, which is a good thing. So I'm going to make sure that when this is clamped down and I machine this, that it's not being twisted as little as possible. You know, you can't avoid everything about this. Then we'll get to the other side, but at least I'll have a good surface to work from that I may not have to shim to get this side in relation to the most important main bearing. Okay, now I will be back, and I brought it to this point, and I will continue. Okay, thanks for tuning in, and I think at this point I'll probably put the picture to show where I am in that photo, if you hadn't guessed. Okay.